All right, how's everybody doing tonight? Have a good Labor Day weekend? One of you did, good. Well, we're going to be going over Chapter 2 tonight, and then we're going to end with a networking video on how data packets flow on a network. We're going to talk tonight about an OSI model and the different organizations within networking professional organizations. Certifications we'll end on as well. If you are interested in Network Plus certification, which we'll end talking about, you can let me know, and I can send you some information. I've already sent one or two of you already some information on getting started. They do offer here on campus. We have CompTA that here on campus, a testing center, and students get a discounted, sometimes free test depending on the certification you're going for. I know for the Network Plus, A Plus, for the test prep and the test both, it's around $100 for a student, which is pretty reasonable. And so anyway, if you're interested in that, we'll talk a little bit about the end of the discussion before we get into the video. The video will be your lab tonight. And so so I won't forget, if you wouldn't mind going into week 3 lab and submitting your name, that would be great. So I won't forget that. First off, I'm going to talk about some job postings. There is a new job, couple new job postings actually, I want to talk about. One's a web developer for a company called Quiet Light Communication. The gentleman that works for them has been coming to the last 2 hack nights that we'll talk about in a second. And they're looking for a junior developer with really not as much technical experience, not that they don't want any web experience, more somebody that can kind of fit into a team environment and be willing to learn. It's a really laid back company, really kind of linear management, and it'd be a cool place to work, really good pay for an entry job. So if you're interested, read the information about the job. It has a link to the website, and then it's mostly PHP. If you don't know PHP, they'll even teach you that. If you know basic HTML, SQL, CMS, CSS, stuff like that. So anyway, that's the first one. The second one is about 3 or 4, actually 2 internships. 2 of them were taken yesterday, so I got 2 left. The way internships work is you work basically 75 hours. For each 75 hours, you get 1 credit hour for an internship, regardless of what the internship is. This one is, I'll click on the link, it goes to the intern needs here. Hour of code, this was a really easy one. Hour of code meets the 4th Saturday of every month. The next one, I think it's like the 24th or something, I can't remember. 24th of September, whatever that is, we'll look at in a second. It's, and all you do is basically pass out handouts, walk around, help people, and there's ages from 6 years old to 70 years old in there. It looks like it's September 24th. And the last one we had in August, had a CIS student come help. And so it's an easy breezy one. You do get, if you do help, one of the giveaways. And I always give away a selfie stick, a couple selfie sticks, and then a charger, a mobile charger. So it's a little something anyway. There's one in September, one in October, none in November, but then there's 4 in December. We're going to do 4 of them back to back in December, starting at 9 a.m. That one will run about 120 people, about 20 per session is what we had last December. And so if you're interested, it's a lot of fun to do. Kind of get to help people learn, and you can go to the website prior to the event to learn about it and what it's all about. It's a lot of fun to do though. So that's one. The next 2 and 3 there on the overhead, the web design. One is for PHP for a local website for a local business. The next is we're meeting tomorrow with RBC board member, not faculty member. She's wanting a website built, and I've got a couple of my PHP students going to meet, as well as a student I've had as PHP going to meet tomorrow. We've got 3 of them, but there's still more room if you want to help with that. It's basically a website, kind of like an Angie's List for home health care. So all things deal with home health care. If you ever had a loved one that's been maybe had cancer or some debilitating illness where they needed care in the home, what this website's for is for people to go there and find home health nurses, equipment, all that good stuff, and be able to read reviews from companies that offer those services. So it's kind of like an Angie's List for home health care. That one, and then the last, number 4 has already been taken. I had a couple students step up and volunteer already, and they're going to become internships at Transform Rockford for the social media photographer spot. So if you're interested in any one of these 3, the Hour of Code, 2 web design spots, just shoot me an email, let me know after class, that'd be great. Or you can come see me before you leave, and I'll jot your name down and get you some more information. Questions on that? Okay. Next is Hack Night next Wednesday. About the last 2 years, I've been on the journey of learning 3D printing. Russ Delaney from Delaney and Associates is a 3D firm here in town. Well, not in town, it's in Beloit, I believe. Anyway, he's come and spoke last couple years actually for me, and really cool guy. If you've ever got a chance to go, maybe some of you did. He just would come and talk for like an hour, bring his 3D printer, print something while he's talking, and at the end of the night, people come up and kind of the last one he did, I asked him to print do a 3D print out of an iPhone case. And so at the end of the session, we did a drawing. Somebody got an iPhone case that he printed during that session. That was pretty cool. And so I'm not going to do anything that extravagant. I'm going to try to figure something out very small, and we'll quick, pretty good in a 2-hour time. But I've been doing it for a couple of years, and so I'm just going to share 3D printing for beginners. If you've ever been interested in buying a 3D printer, equipment, supplies, a design application type platform, I'm going to show you all the things I've learned and just share that with you. It'll be just about 30 minutes. So if you need to do something later on that night, you can come from 6 to 6:30 or something. We are going to have pizza as always for that. We've been running about 14 or 15 the first 2 weeks, so it's in this room here. So again, it's in this room, 6 to 8 next week. I'll show you a picture of the latest printout I did. It was a phone stand for the CIS division we did as a giveaway last semester. And so that's it right there. And so basically it's just a phone stand, and it has the letter CIS there on the side. And it took about 6 hours to print that, something like that. And so I won't be printing that next week. I'm going to print something smaller than that. So anyway, it's kind of cool if you're interested in it. 3D printing is, not going anywhere. It's going to be in the home. It already is a lot of consumer homes for printing out, like, say, parts that break around the house. I got a 3D scanner, and I can literally scan anything and replicate it on a 3D printer now. That's pretty awesome. But one of the things you'll also be able to do, they're experimenting with 3D printing food. I was a chef going through school, and so I found an article in the UK where chefs are building, they've already had the printers already built, and they're using it for elderly who can't chew food, right? They're like, just can't chew food. So they print food that looks like steak, looks like potatoes, but when they go to eat it, it dissolves in their mouth. And it's all done in 3D printing. Now, I don't know how it tastes. They said the reviews I've heard have been kind of mixed, but kind of cool. And you might have heard there's actually a thing going, I think it's in England, they're doing this next summer, they have two robotic arms that are going to, one on each side of the river, and they're going to build a bridge it's a metal 3D printer. They're going to meet themselves in the middle with this mechanical arm, and the way it's supposed to work is they put in the design in the printers on both sides, and they just let it go. They just feed it metal rods, and it just prints. And it's supposed to meet in the middle. I've done some smaller kind of, you know, demos inside of shops and things and been successful. So it's about like a 30-foot span or something that's going to happen. So that'll be kind of cool. There's been 3D printing on the moon. There's been 3D printing where they can build houses in third world countries for like $5,000. Build a nice big, like a room like about this big. Can set up a 3D printer that literally builds walls and rooms and everything like that for a reasonable price. So anyway, if you're interested, come next week and I'll share with you what I've learned and hopefully maybe save you some money if you want to get into it, because it can be expensive. And, you know, so Russ, I was thankful to have Russ that I could lean on to help on what to buy, what not to buy. And so he's kind of an interesting guy. When he first started 3D printing, anybody like the movie or the series Thor? Or you're into Thor? Anybody? Okay. The first movie they did of Thor, the hammer, in that movie, he was contracted out to create the prototype for the movie. So when they were filming it, he was sent the specs and won the bid to print the 3D prototype. And that was about 15 years ago, something like that. But super nice guy. I'll have him come again, probably, if not this semester, next semester. If you ever see it promoted, you definitely want to go. He's pretty awesome. Hour of code, we talked about that. I think we had, I don't know, like 15 last time, 14, 15, I think, something like that. And thank you, by the way, for helping last time. Appreciate it. RBC Tech Expo, 46 days left. It'll be here before we know it. I think we've got 89 signed up right now, RSVP'd. If you've not yet RSVP'd for that, it's on a Tuesday night, October 25th. And the way what's going to work is basically we're going to have 4 speakers from the tech community talk about jobs that they have to offer, jobs that they hire for, and what skill sets they need. Then after that, you guys will get a little card. You'll walk around to the tables. You'll have some questions to ask each company, and they'll stamp your card if you ask like 3 or more questions. And it'll be questions like, you know, what technologies do you need to know to work with your job? What type of training do you recommend? Things like that. And then anyway, after you fill up your card, you'll come up, drop it in a fishbowl, and there's going to be some drawings for at the end of the night at 6:55 or 7:55. It ends at 8, so you have to stay all the way to the end. But the first drawings for 4 credit hours that you can take any class, 4 credit hours starting fall 2017. And then the second drawings for an iPad mini. Third drawing is for a wireless USB Wi-Fi stick that basically you sit on a table, turn it on, and you can share Wi-Fi to a small group of people and share files. So you can go to the RBC Tech Expo to register for that. And questions on that or anything I've mentioned thus far? Okay, cool. So let's get started. Week 3, OSI. OSI is the 7 layers of networking we're going to talk about. We're also going to talk about some organizations and certifications, a part of networking. It might not be the most exciting part of networking, but it's something you need to know about. Not everything that you do in life, regardless of what you decide to do, is going to be exciting. It's just stuff you got to know, or good to know anyway. So let's talk about what's due this week. Thank you for turning in your topic for the assignment for the semester. If you've not yet turned in your topic, I believe it was due Sunday, if I'm not mistaken. Is that right? If you've not yet turned that in, go ahead and do that. If you have questions about it or whatever, say you submitted your topic, you want some help maybe on honing down what to, you know, kind of narrow down your topic. Like I know a student of mine from my last class, pct110, she's wanting to do hers on the Enigma machine and breaking it down into encryption. How that was actually the first encrypted type of machinery in computers was the Enigma. And so she's going to do hers on that, and I helped her with kind of narrowing down what to focus on. So if you need help with that, let me know. I'd be more glad to help you. So let's see. Lab, I had your new username on that. Week 3 review questions for Chapter 2. Make sure you do that. And Chapter 2 quiz. 20 points. It's going to be 10 questions, multiple choice. You can take it up to 3 times, highest score out of 3. Questions on homework? All right, so we're going to talk about network standards, OSI model tonight. We'll end with a video. It's a short video, about 10, 12 minutes, on how network packets flow across the network. So what happens when you click on a link on a website, what happens, how does the data get from the web server in China to your computer? That's what the video talks about. And so it's a pretty cool animated video. It's kind of cheesy a little bit, but it's pretty, it explains all the technologies that goes in the back end of how data flows. So I think you'll like it. So there's tons of organizations we're going to talk about tonight, and then end with the OSI and the different types of certifications. So first is some standards, like in every business, every type of job you go into, whether it be nursing, doctor, lawyer, construction, restaurant management. You're going to have some type of standards you got to follow, right? Same thing in networking. There's some standard agreements you got to fall upon when it comes to setting up networks, and that goes to hardware manufacturers to software manufacturers. Everything from cabling, like we're going to do in a few weeks, to switches, to routers, to hubs. But it's a technical specification on what's required, and it's generally minimal requirements. Okay, like an example would be, what's the standard memory for a Windows server installation? Okay, there is standard minimal recommendations that definitely would never use because it's way low, but there's standards that manufacturers have to put on the box. Same thing with Wi-Fi routers, things of that nature. But it basically stipulates the design and performance of a particular product or service. Standards are essentially, in the networking world, have to do with hardware and software. There is people that make a living creating standards and governing standards, believe it or not. So if you're into like meetings, writing stuff, creating rules, you might want to become a member or a board member on one of these organizations we're going to talk about. And over the years, I've worked with people that have been a part of these boards, and they loved it. Personally, I wouldn't love it. It's just too boring to sit in meetings for 8 hours, but it's just me. But we need people like that can do it and can stand it and can lobby for, cutting edge technology and things of that nature, and, put up with it, politics and stuff. Me personally, not my bag, but for some of you, it might be. And so, standards define a minimal acceptance of performance, not an ideal performance. Like I said, an example would be, a Windows server say, okay, 32 gigs of RAM or 16 gigs of RAM for the newest network operating system for Microsoft. On average, 128 gigs or higher generally is what most places do. But even on a consumer side, if you buy Microsoft Windows 10, it tells you, okay, here's a minimal requirement for home users for memory. And it might be, 8 gig, 12 gig, whatever it is, okay? Is that ideal for most of you? Probably not. You probably want the most RAM you can get to where you can get the job done, right? Same thing with minimal standards for hard drive space, minimal standards for processing power and processing speeds. And so all these are minimal standards, not ideal performance, just minimal. And there's many different organizations that oversee these standards, which we're going to talk about in a second. Two of the big, or for wireless, would be ANSI and IEEE. They set the wireless standards. If you look on a Cat5 cable, you'll actually see ANSI and IEEE logos on the cabling, stamp of approval that they approve these cables. Now, you might be thinking, man, there's probably a lot of red tape when it comes to new technologies, like, say, new Wi-Fi technologies. Yeah, if you go to like China, if you go to, just say China as an example, in Japan, they're probably 4 or 5 years ahead of us when it comes to wireless technology. Okay, but it's it's not secure, but they're using stuff that we're probably going to be using in 3 to 5 years in the States. Does that make sense? The one thing the book doesn't talk about either much at all, but I'll talk about it, is most of the Wi-Fi standards that we get come from military testing. Like right now, they're testing the cutting edge next generation Wi-Fi for us. And that makes sense for the military to be one step ahead of everybody else. So when we get some type of Wi-Fi technology, they're already using something 2 to 3 steps ahead of the states, if that makes sense. Now, we're still at the state though. We're not there at this in Wi-Fi technology to where they can trust Wi-Fi technology in the field for communication. It's still not quite there yet in some Wi-Fi type of devices. It's going to get there. It's just not there yet. So, but the military does a lot of the testing, which a lot of people don't know, for anything wireless and security and encryption. Network professional responsibility would be, you just need to be familiar with stuff, but familiar with the standards, familiar with the organizations, because it does affect everything it's one way or the other affects everything you do in networking. The hardware you buy, the software you buy, the way you set up networks, things of that nature. It's going to affect you in one way or the other. ANSI is one of the first ones. It's American National Standards Institute. Has about 1,000 plus industry and governmental folks involved. So you kind of have checks and balances between folks in the office doing the work and government people like in Springfield that pass laws to say pass a new Wi-Fi standard or pass a new FCC to allow drones to fly in rural areas or something, as an example. It determines standards for electronics industry and other fields. It does have voluntary compliance on ANSI. In fact, any of your Wi-Fi routers, when you go home, on the back of them, will more than likely have like an ANSI stamp of approval on those. Like any Linksys routers will have that for the most part. Belkin, for the most part, will have those on the back. And it just is that stamp of approval from ANSI organization that they're approved for electronic standards. Also, obtaining ANSI approval is rigorous testing. It can take up to years to get testing approved. That's why we're behind some countries when it comes to what we get on the state side. ANSI standards are also available online in white paper PDFs, like thousands of pages, some of them, which is good, fireside reading on the weekend when you have nothing to do. You can just read an ANSI white paper on wireless technology or something. That'd be interesting to do. None of you will do that, but hey, it's there if you want to. EIA, Electronics Industries Alliance. This is a trade organization in the U.S. From all manufacturing type of firms. So some like Woodward, Sunstrand, Eiger Lab, Ingersoll, just to name a few around here that definitely would be into electronics or dealing with electronics in their industry. They set standards for its members. They help write ANSI standards. They lobby for favorable computer electronic legislation. An example, one of the most recent was FCC passed a law, went to the FCC finally on drone registration. If you have a drone, you have to register if it's so many ounces or greater. You have to register on a website. I think it was you had to pay $5, and then they gave it back right to you, if I'm not mistaken, when I registered mine. I think if you passed a certain date, you had to pay $5. But anyways, just so they kind of know where all the drones are out there. Part of the group that was a part of pushing that. TIA, telecommunication industry. These guys were formed in '88. They are a subgroup. EIA was a subgroup formed with the former U.S. Merged with the former United States Telecommunications Suppliers Association. Focus of TIA is standards for information technology, wireless, satellite, fiber optic, and telephone equipment. This next one's one that you'll see on the cables when we do the cabling lab. The TIA EIA 568B series, that's the standard for Ethernet cabling. And it's the guidelines for, the wire that runs in the middle, the plastic shielding, things of that nature. Let's go by that. IEEE, and Institute of Electrical and Electronic Engineers. International engineering professionals. The goal is to promote development and education. They host symposiums, conferences. They do have student chapters too, by the way, where you can get pretty good discounts for magazines, 2 or 3 yearly conferences in Chicago, like all-day conferences, where you can do challenges on everything from networking to coding to whatever you want to get into as far as encryption is there too, setting up routers and switches. So on these conferences, they also have tutorial-based stuff where they teach you it, and then right after that, you have a challenge, and you compete with other people that go, other students from around the nation. So it's kind of fun to do. I've had some students get involved with the IEEE student chapter. They used to meet at at Rockford College last semester. I'll find out where they're meeting now. They move a little bit, and I'll tell you where you can sign up and everything. And they do meet downstairs in the bottom floor, first floor, periodically, like once or twice a semester. And usually about 75 or 80 people show up, and students are also invited to that. They feed you, and they have a little presentation on some new technology. I think last time they did one on, I have some at the house. You guys seen these devices you can plug in the wall, and then you can set up light bulbs to remotely control from anywhere in the world with your phone. You seen those? There's a number of different providers, like Belkin's one that has a unit out for $50. It's a little white square you plug in the wall. You set it up on your Wi-Fi. Then they have light bulbs you can also put all throughout your house, and then you can manage your light bulbs remotely from a phone, turn it on and off and stuff. That's one of the things they did last semester when they were demoing some stuff. Highly respected group, though. ISO, International Organization for Standardization. These guys are headquartered in Switzerland. Oh. Box died. There we go. They're headquartered in Geneva, Switzerland. I've always wanted to go to this one. This one, actually, I just want to go because it's in Switzerland. I always wanted to go there. They have some cool pictures of some of the conferences they've had there. And 57 countries are a part of this. The goal is to set international standards for free trade for technology. So third world countries that need computers can lobby here in the ISO organization to get help, okay? And whether it be through United Nations, whether it be through some charity group, raising money, whatever. The need is a Raspberry Pi you might have heard of. Raspberry Pi, the little computer about the size of this remote here, originally set up through ISO to help third world countries. They could build one for about $20 a piece and sell them about 35 a piece, I think, originally. And now it's, everybody, they're everywhere. You go to Barnes & Noble and see them there on the shelf. But it started out as an ISO push for third world countries to get computers. I'll bring mine in one of these days to show you guys. I have a little setup I did for the Raspberry Pi, and so it's kind of fun to do. So these have widespread authority across geographic boundaries, and again, well respected. The ITU, the International Telecommunication Union, they specialize in United Nations agency. United Nations started in 1947 with the advent of bringing the nation of Israel back as a nation officially is when it started. And so they regulate international telecommunications, provide developing countries with expertise and equipment. It was founded in 1865 and then joined the UN in 47 when it came about, after Israel came back on the scene. And members from 191 countries. Focus of these guys is global telecommunications. They do a lot of fiber, transoceanic fiber lines in between countries to get access to internet, basically. Worldwide internet implementation is their goal, and free. Their goal is to do it for free, and they do a lot of free internet providing in third world countries in Africa, Sudan, just to name a couple that's definitely cannot afford to get any type of internet connection. And so kids in like Sudan and Africa can actually take school and college and online where they might not have classes or even school buildings. They can get education online through the focus of this group. ISOC, Internet Society, is founded in '92, a professional society to establish Internet standards. Current ISOC concerns: Internet growth, Internet accessibility, information security, stable Internet addressing, open standards. These are the folks that are behind the new version, IP version 6. We're now using version 4 in here, and most computers are still. But version 6 is out, and all your modern NIC cards support it. And basically what it is, in a nutshell, to be simplistic, is it just gives us more ability to have IP addresses, more IP addressability, basically, throughout the world. As you can imagine, websites for commercial and personal use both eventually would run out of IP addresses. And so that's what this group's concerned was with, one of them. And so their answer, and it is a good answer, is version 6 of IP. ISOC oversees specific missions, like they have an Internet Architecture Board that oversees Internet's design and management. And Al Gore is not a part of that group, surprisingly enough. But that joke used to go 3 years ago, but now some students don't even remember when Al Gore said he invented the Internet. But anyway, anybody remember when he said that? Okay, you saw it on the news. IETF, Internet Engineering Task Force. These guys set the Internet Systems Communication Standards, and they have protocol operations and interaction with other groups, and anyone can submit a standard. When it says anyone, I used to be on, I was on a board for grants, writing grants. If you've ever known anybody who wrote grants or you've written grants yourself, when you write a grant for something, it's always like, okay, it's got to be 150 pages. You got this, 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 and this. And what the group that take these grants in, the first thing they would do is just look and see if the people followed the steps. If they didn't follow the steps on the requirements, they didn't even read the grant. So if it's 150 pages, you only had 149 pages, trash. So they say anyone can submit, but there are standards you have to go by to submit them, which it is, you could say, it does deter people from submitting that aren't really serious about submitting, probably. But there has been folks submit things in there, like an example would be, free internet for the Sudan would be an example of ways to do that, and to maybe bend some standards to get internet in places that aren't there, maybe by using satellite, where maybe they can't run Cat5, they can't run fiber, but satellite might be a technology that can be used. It's elaborate reviewing, testing, and approval process that can take a while. IP, protocol address, Internet protocol. They identify addressing computers. It's reliance on centralized management. And the history of this group started out initially as what's called an Internet Assigning Numbers Authority. In '97, there was 3 registrars. You guys have heard of like GoDaddy. You've heard of maybe Network Solutions or something. But there used to be in '97 just 3 originally when the internet started really growing. People started buying websites and things. It was the American Registry for Internet Numbers, the Asian Pacific Network Information Center, and the Rosa IP Europeans. All 3 were, geographically driven, depending on the region that the business was buying the IP. Then in the 90s, it became ICANN, which is an Internet Corporation for Assigned Names and Numbers. It's a private nonprofit. It is a kind of a quasi-governmental as well. The government does fund it a little bit. They write grants every year to get funding. Remains responsible for IP addressing, domain management. So even though GoDaddy, Network Solutions, all these other people, you can go to type in a domain and buy one easily, right? Anybody can. These folks will want to keep track of what they all are and keep a database of all of them. They perform system administration. They're behind, if you've ever set up a website, enforcing the who is. The who is of a website is basically what it sounds like. who owns the website, how can we contact you, what's your address, things like that. Okay? Yeah.
Isn't that being taken over by the UN?
Yeah, yes, you're right. It's in the process of being taken over by the UN. Yes. I don't know when that's going to be official, but yeah, that is in the process right now. It'll be interesting how that works too. I don't know. We'll find out. But good for the UN, but I don't know if, and I'm guessing from what I've heard, these people that are over it now aren't going to go anywhere. They're just going to be like under the umbrella of the UN or something. So, which that'll be a good thing. So they won't lose their technical folks. But it'll be, the UN will be like a governing umbrella, I've heard. So, users and businesses obtain IP addresses from an ISP, like an example, Comcast. Okay, if I own a business here and I have Comcast come in and set up a business plan for my business, and one of the questions they ask is, are you going to have your own web server? Yeah, I'll have it. I'm going to have my own web server. Okay, we're going to give you 3 external IP addresses for your location, and those 3 external IP addresses are just for your business. Nobody else can use them. And so, you times that times however many businesses are in the country, which I'm guessing is millions. It can be quite a big task, but the umbrella of that whole piece is the ICANN. They keep track of all those numbers and keep track of all the folks that own those IP addresses or loan those IP addresses. Because if you stop paying Comcast or stop paying whatever provider, ISP provider you have, for a time it's on hold and then it goes back in the pool. Those IP addresses do. So I guess you don't never own them. They're just like given to you for a time while you have that website. OSI, let's talk about that. Is developed in the 80s, and the whole purpose of the OSI is a philosophical model for networking, meaning, like any model, it's imperfect, but let's say, okay, your computer won't talk on the network, okay? So what this model's for is saying, okay, then maybe it has to do with the NIC card, okay, where there's a portion of the OSI model that literally has to do with the NIC card only, that hardware device. And then maybe it's software, maybe it's your web browser. Okay, there's an OSI model we'll talk about for application, OSI model for session control, on making sure sessions stay alive when you're on the internet and you're communicating via video or text or chat. So it divides the network into 7 layers: physical, data link, network transport, session, presentation, application. The physical is physical, it's your NIC card, okay, and those components that comprise the NIC card. You could even say the wire going into the NIC card all the way to the switch, that would be a part of that whole physical layer of the OSI. The data link, network transport, session, presentation, application, the rest of them. So it's protocol interaction. It usually on the layering interacts with the layer above and below. It can overlap layers. And it's not software. It interacts with software on the application side. The physical layer are protocols that affects cabling, affects connections. A lot of companies will say we're like a level 2 or level 3 provider for networking, where they maybe fall upon the application layer, the session layer. It's theoretical, between 2 nodes, hardware and software independent. Every network communication is represented. They have what's called PDUs, which are protocol data units, discrete amount of data, application layer. It flows through layers 6, 5, 4, 3, 2, and 1. And it's a model and imperfect. So here's what it looks like. We'll look at the top right first. You've got basically we'll say you are there and you're on Eagle and you submitted your name. It's going to go down through the application layer, which is what browser? What browser did you guys use tonight? Anybody? Chrome, there you go. Chrome web browser. It works through Chrome. Then goes to the presentation layer with your data. Presentation layer is going to go to the session layer. Now the presentation layer is going to take what you submitted in Eagle, which was your name. Okay, it's going to be in digital format at this point, but everything on the network travels in binary, zeros and ones. Right now on your Chrome web browser in Eagle, it's all digitized, digital information. So the presentation layer is getting ready to package it up, to push out, getting ready to package it up to the network, pushes through the session layer. The session layer is the communication side, meaning when you logged into Eagle, it keeps your username and password active for a certain period of time, right? Eventually, if you sit there on Eagle for long enough, it's going to time out. And when that happens, you lose your connection. So the session layer keeps you connected. Then it goes into the transport layer, which is getting ready to take and package your data and bring it into the network. The network layer and the data link layer are now converting it into binary. The physical layer is your NIC card, and now it's going out into your network. Hits your network, goes to your Cat5 cable, goes to the switch, goes to the servers, comes back to the computer you're sending it to, which is the Eagle server. Goes through its physical layer. We'll say it's in California. It's NIC card there, data link layer, transport layer. Now it's converting that binary back to digital. Transport layer, session layer, it authenticates you are who you say you are, and you are who your computer says it is, okay? Your IP address, your MAC address, the size of file you sent is the same size as when it received. Presentation layer, and then finally it's going to show up on the Eagle file server somewhere in California in a web server somewhere for me to see. Oh, you sent your name, I can give you 50 points now for that lab. When it comes back, you see that the message is there, your name is saved, done, right? That all happens like that, right? But, you know, you literally traveled thousands of miles maybe to get that process happen in milliseconds. And so every one of these layers work with one another. Again, they can overlap. The top layer is the application layer. It has no software in itself, it's just a model. It works with software like Chrome. Protocol based, meaning it's going to work with digitized protocols within your computer. It's going to work on ports, like in a web sense, it's going to be working on port 80 to send your stuff out through the router. On their side, it's going to be going into port 80 to accept it. If you are on a website and you are uploading website stuff for your website, it might be FTP protocol, which would be port 21 you'd be working through. The network interprets the application's request. In this case, it's a submittal of text in a text box that you type your name, and then it interprets it and sends it through the network. The software negotiates with the application on security. Do you have rights to send this? Are you a student of my class? Yes. Synchronizes it and sends it. Presentation layer then accepts that layer of data from the application layer, formats it in a way it can be understood. An example would be like encoding. You've heard of, maybe you haven't heard of encoding, but encoding is where you take any data and encapsulate it with something, or wrap it around it. So text would be a text capsulation. If it was a video you sent me, it'd be a video capsulation, like an MP4 encapsulation. If it was a sound, an audio MP3 capsulation maybe. So the presentation layer performs coding around it and compresses it. Example on this one is the presentation layer services manage data encryption and decryption. So as it's going through, it's starting to encrypt the data before it sends it. The session layer protocol here, it coordinates and maintains communication between two nodes. Like I said earlier, keeps things alive. It's a simple way to think of a session layer. Anybody remember dial-up modems? Anybody remember dial-up modems? Okay, when you started a dial-up modem, what happened? What did you hear? Anybody remember that?
Yes.
Yeah, it's like, you know. Then finally, once it would connect, it would stop the noise, right? During that shriek sound, though, that session was handshaking to make sure you are who you say you are. Once it authenticated, then it connected, and then an easy flow, sound ended, right? That whole connection time of sound was a session layer of you could say the dial-up modem. So that you could say the dial-up modem falls heavily upon the session layer. And because it's communicating ongoing connection between remote and access server and between web browser and web server. So when you send your stuff through Eagle tonight, you're on the web browser Chrome, send it through, the session layer validates you are who you say you are and you have the rights to send it. If, let's say, for instance, it timed out, you typed your name, you waited 10 minutes, then you hit submit, Eagle might say, or might redirect you to log back in again. I don't know. Probably more than likely it would do that if you're logged out already. That would all have to do with the session layer here. Session layer functions, keeps things alive, keeps your session alive, keeps it secure, continual dialogue of synchronization. You know, you'll see this on the video. It's constantly going, are you there? 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 Oh, okay, you're there. Okay, are you there? It's just constant, are you there? All the time. All the time checking if you're there and if you're connected. Another example is, you guys ever downloaded a file from the internet and it started downloading really fast and then it went really dirt slow? Yep. You ever had that happen? You ever had it happen to where it literally stopped downloading altogether, stopped it? You're like, man, well, it's done. No, it's still connected. It's just literally, you can't see any movement, but it's still there. What's happening here is that session's still alive, but when you start downloading a file, web servers have a thing called load balancing, to where what they can do is it determines your connection, their connection, everybody else is connected to that same web server, and then it starts throttling down the download speeds. So it knows for sure if it throttles it down to such as 100 people connected, if I throttle it down to this level, everybody's going to get that file that they're wanting, right? If I keep everybody up here, stuff's going to die, maybe crash the server possibly because I'm overworking it. So it'll throttle the download speeds on purpose. So the throttling generally is not happening on your end or on your ISP provider. It's on the web server end the throttling's happening. Because I've heard people say, well, I think Comcast or Xfinity is throttling my download speeds. They could do that, but more than likely that's not the case. It's being throttled by the web server through a bandwidth type of throttling on purpose. So the best time to do downloading, you probably know, is late at night, past 10 o'clock, past 11 o'clock. If you're going to download, a Microsoft Windows from the server on Microsoft's website, late at night's the best time to do it, when most folks are in bed and not downloading stuff from their servers. That makes sense? So the communication starts a transmission. It can even seemingly stop it, but then restart it again. And sometimes that happens as well. Maybe did stop it, you're not seeing much movement or no movement, then all of a sudden it starts back up again and starts downloading the file. Terminating communication is also done in this. So when you log off of Eagle tonight, you terminate that session. If I come right behind you and try to, submit something, it's not going to let me in until I sign in with my authentication to let me in. Transport layer, this accepts data from the session layer. It manages end-to-end delivery, handles flow control. It's connection oriented on the transport layer. What it means by that is it establishes connection before it transmits data. It's already seen the web server side in California and seen what it can handle and how it's best way to get there already before it sends it. As a checksum, and all the checksum is for is checking the file size and the integrity of the data when it sends it. It adds a checksum file check to your file before it sends it as kind of a key on the other end to make sure this is your file you sent at this time in this location and this file size. If any tampering occurs, it restarts the session again and sends it one more time. The connectionless protocols is also in there, so you have connection and connectionless. Connectionless is basically that there's no establishing connection with another node before transmitting, no effort before delivery, more efficient than connection-oriented, useful when data must be transferred quickly. This happens within Eagle when you're uploading data within Eagle. It's its own ecosystem. Because it already knows you're authenticated, it can use a connectionless protocol to send files within your Eagle session. Segmentation, this one's kind of like a caboose on a train basically. You can take basically this crude example here. See if I can draw a very crude caboose here. A little bigger than that. That. Do red. Okay. So we got the train with a whole bunch of cabooses. And what's happening is on the data, it's segmenting that text file you just sent across, which is your name. And I'll just, for example's sake, I'll just put my first name in here. Okay. And each letter has its own segment, and it's sending across the network. And the reason it does segmentation is for surety of data delivery. And so it breaks up large data into smaller chunks to make sure data gets there. And it can literally be scattered in millions of pieces. They're all numbered numerically, by the way, when it does this, meaning it starts with 0 and goes to whatever on the end, okay? Whatever that number is at the last caboose in that segment. On the other end in California on the web server, when it repackages everything, it uses that segmentation numeric, brings it back in, caboose by caboose till it's all together, checks the checksum, validates it's there, successfully delivered. Maximum transmission units also part of this transport. 1,500 bytes per caboose, you could say, per segment. And reassembly is a part of it, well, as I already mentioned. So on the other end, it reconstructs the cabooses together in the segmentation of the data and package it for delivery. And then also successful getting on the other side. Sequencing is basically identifying the different parts as they come in, the different cabooses from 0 to whatever. So we have a long message sent across the network. This one puts it a letter in each box, like I did earlier. Much better drawing than I did. And then, so it's going across the network, reassembles it on the right side, and so the recipient gets that message. It's that simple. This here is a screenshot of an actual transport layer protocol, and you'll notice on the top end on the source port, port 80, anything that's HTTP is always going to be port 80, okay? Port 80 is for all things web related, all things internet related. Destination port, 1958. This is usually created by the network on what port is available, and then it just grabs onto it. Sequencing number, acknowledgement number, header length are all part of that package of checksum. The flags, if you've ever seen a NIC card, if you were to look at the back of the NIC card, it has lights on it. And these lights are corresponding to this one. These lights are also, when we remember dial-up modems, they also had lights on them as well. They tell us things as congestion on the network, whether something's been acknowledged, something's been sent. In this case, there's two flags that are set to true, acknowledgement and that it was set, meaning the data was acknowledged and set as being valid data from where it came from. The window size at 5840, that's basically been around since the old DOS days. They did up it from like 36 or 640 to 5840. Has nothing to do with your window screen size. It literally goes back to the days when we used to transfer data on the black DOS screens, and it would tell the black DOS screen how big the screen was for that data to be pushed upon. Well, we don't even use that anymore, but it's still in the checksum. It's still in the package. The checksum, notice it says correct, because that checksum is encrypted with a unique encryption. It comes back, and that checksum has to match the checksum when it's received. 4 bytes options means each one of the segments was 4 bytes. and the maximum segment size 1460 on this one. Network layer is the next one. This one protocols translate the network into a physical addressing, decides how to route data. It uses such things as the router, the switch, to determine the different hops it's going to take to get to California from here. It might take 30 hops, might take 15 hops, might take 10 hops. Every hop is a crucial step in your data getting there. And what really matters is that the data gets there, not really that it gets there real quickly, but it gets there. And so your network in this function will determine the fastest way to get there, but really more so the most efficient way for data to get there. Addressing is where systems assign a unique identification number for network devices. So for instance, the switches in here, the routers all have a unique addressing for our network. And types of addresses for nodes would be a network address and a logical address. And again, they're assigned by the network. The network also has packets, and you'll see on the video in a second, where basically the packets are the data, the payload of the data that transports a logical addressing information, source destination, IP destination. So your IP address, the web server in California's IP address, your MAC address, the MAC address of the server in California. And when I say MAC address, some of you might not know what that is, and we'll talk more about it when we do the NIC card, but MAC addresses are actually embedded on the NIC card in manufacturer, and it's a unique number, kind of like the VIN number of your car, okay? And a MAC address is made up of both the manufacturer name, they have like a unique name in the MAC address, and a random number, but they're all unique. Routing considerations, they'll look at things like priority, network congestion, quality of service, cost of alternative routes. Common network layer protocol would be IP. IP in and of itself is with no rules, it's totally open for network to flow. And then fragmentation is a lot like the caboose one we saw earlier, but it's for the internal network only to send the data before it goes out of the router. So inside this network, there would be a segmentation before it gets to the router. There would be another segmentation between the router and California to get the data. Here's a network layer screenshot. Difference on this one you'll notice is right here. Source IP, destination IP. Other one you might note is flags are much more minimal. This one has no fragmentation whatsoever. Time to live, 64 milliseconds. It can live, or 64 hops depending upon the network that it's on. This one's protocol is TCP/IP, and the check set again is right here, and notice it's correct. It checked it, that it's correct both in the data that was sent and received on the network. Now the data link layer. The data link layer is to divide the data that's received into distinct frames for the transmission on your Cat5 or your Wi-Fi or your fiber, whatever it is your network's backbone is. The frame is basically structured to move the data, so you've got your payload, which is your text that you typed in to submit tonight in the lab. The sender's and receiver network address, error checking, package, and then control information is all wrapped around it. There is possible communication mishaps that can happen. You'll see this on the video where IP packets drop. What happens is that California will say, its server will say, I didn't get this IP packet. It'll request it again from you, and Eagle will send it again, the same IP packet. So say it has 1 million IP packets and it doesn't get the last packet for whatever reason. It'll just resend it again. There is some redundancy, by the way, on data packets being sent, but that's on purpose. And there is packages that are going to be dropped because of redundancy. And so, again, that's on purpose as well, to make sure the data gets there. Error checking, it checks for frame sequence from 0 to whatever. It also checks what's called CRC, cyclic redundancy check. That's what I just talked about earlier, just a second ago. You could have a caboose sent multiple times, like 10 times, 100 times. It's going to check that and throw out all of them, but one that it needs. Possible glut of communication. This one basically allows a NIC to process data without error. Your NIC card falls upon this data link layer. Your NIC cards aren't made to control data flow. They're just made to allow data flow. So that's why there's no check set of input or output of data. It's just allowing data to go in, allowing data to go out. That's all it's doing in this one. There is some sub-layers of the data link. The LLC, which is logical link layer, and then the media access layer. And these actually work with a MAC address exclusively. I already talked about the MAC address, but it's a block ID that's just a 6-character sequence to each vendor, and then a device ID, which is a 6-character number added at vendor's factory, which is a random number that they use for that. The MAC address frequently is depicted in hexadecimal, and MAC addresses can be, and we do this in my 130 class, MAC addresses and IP addresses both can be spoofed in a man-in-middle attack, but what's going to happen is that checksum is going to change. And so the most communications, if they're encrypted, in fact, all communications, if they're going to be encrypted, will notice that change of interception and resend it all over again. And if it happens again in the interception, it could just fail altogether and won't allow that communication to happen. This is a screenshot and a blow up of a physical layer. It blows up that layer and shows you what's happening. Basically on this one, you have the data flowing from the NIC card, getting ready to go out into the network. This is just giving a blow up here of the MAC address, which is right there circled in red. And popular MAC addresses, or MAC manufacturers, 3Com's a popular one. Intel has a few, but 3Com's probably the most popular, I would say, still. The physical layer accepts data frames. Copper transmission medium, that would be Cat 5. Could have fiber optic, would be either glass or plastic in the medium. Wireless, electromagnetic waves. The physical layer detects and accepts singles, it accepts singles. Pass on the data link layer. It's set transmission rate, monitors data error rates, has no error checking on this one. It just wants to get the data out. An example of this layer would be hubs and repeaters, not routers and not switches. Remember we talked in week 1 or 2, I think it was week 2, how hubs are they're dumb devices. It would fall upon this one. Repeaters are also dumb devices. They don't really do any rules. They just push data and extend data. NICs operate both at the physical layer and the data link layer both. So we have application layer, presentation layer, session, transport, network, data link, and physical layer. These layers, by the way, you just need to know the definition of them and the acronym for all of them. The name and definition of them when you do a Network Plus exam. And there are some colorful acronyms I can give you to help on memorizing the OSI model. And so, yeah, definitely if you ever want to take it, when you get to that time, let me know. I can help you with that. Now, communication between two systems, you've got your data transformation where you've got your original information, your original software sends your text file that you just sent tonight, has a generated what's called a PDU from the application layer. The segment sends it out into cabooses, packages it together, puts it in the frames, sends it out, encapsulates it. And so you'll notice how the overlap can happen from the application down to the physical. And where it overlaps really the most in networking anyway is going to be right in this area here where it overlaps the most. And that's just because how close in proximity network, data link, and physical layer are on getting the data and what each one of those three are doing. Frame specifications, all you need to know on this. was developed by Xerox. The term Ethernet was developed by Xerox. 4 types of Ethernet frame, and one of them has to do with IEEE 802.11, which is Wi-Fi, 802.3, which is going to be the kind of wire standard connections, and then you have other 802 standards as well. Token ring, developed by IBM. This relies upon direct links between nodes and ring topology. It's nearly obsolete. A lot of military and old research facilities still have total ring topologies. And ring topology, I think I mentioned last week how a lot of times ring topologies, your computers have 2 NIC cards, one for input, one for output. It's 802.5 standard on that. Ethernet frames and token ring will not interact with each other. It's kind of a self-contained system, and devices cannot support one another on a physical layer. IEEE Project 802 has to do everything with the network backbone. So connectivity, network media, error checking, encryption, emerging technologies. There's new Wi-Fi standards coming out right now in the next year that will be worked through the IEEE. And as far as all the device manufacturers like Linksys, like 3Com, will be working with IEEE, testing, they're already testing IEEE standards already for that. 802.3 is Ethernet, 802.11 is Wi-Fi, as I mentioned earlier, wireless. And here's all the other ones you probably haven't heard of, but I'll mention a couple that are kind of interesting. The mobile broadband, 802.20. This one is actually designed for what's called mobile WiMAX. Anybody heard of WiMAX before?
Yeah, Sprint had it.
Yeah, Sprint. And Clear Communication too, out of the Schaumburg area.
They went bankrupt, didn't
Did they go bankrupt?
Yeah.
Okay, because I didn't know if that was finalized or not, but because they used to have a place on Schaumburg Mall like a year ago or something, but they were struggling then when I talked to them because it wasn't in Rockford. I just asked them when they're going to be
they? Well,
coming.
Sprint and then they were combined. So Sprint put all their money into their technology.
Gotcha, they took
and
over.
They went under. And
Okay.
so then Sprint had to buy like US Cellular's LTE.
So they took over that whole system, I guess. Okay, cool. Well, that's good for us. I think eventually it's going to come our way, I've heard. So I don't know when it's going to be,
Got it.
but
I think it failed.
Oh,
lost
did it?
LTE.
okay, too much money.
I think so.
Yeah, it's pretty expensive. But WiMAX, if you don't know what it's about, is literally if you have it set up in communities, you can be anywhere from a 30-mile radius of the towers and get internet connection if you have the right devices to talk to it. The cost probably, in some areas was too cheap. I heard that's why might be why they went under Clear Communications. They were trying to compete with Comcast and Xfinity, and really with the hardware cost, it's really expensive to set up. But there are some communities like Kansas City. I think it's a couple communities in New York, on the East Coast and West Coast both, that have the whole community set up on WiMAX basically. And it can be done, and grants can be written to help because it is expensive, but it's high-speed Wi-Fi internet connection, which is kind of cool. And that's 802.20. Then the other one is 802.22, wireless regional area networks. It's wireless broadcast network operating on UHF, VHF, the same as your TV channels for the rabbit ears, same frequency. And that's actually been used in Alaska and remote areas, fairly successful, and actually not as expensive to set up as WiMAX. Not as fast, but not as expensive, and people can at least get internet connection. So those are some I thought I'd mention that's kind of interesting. WiMAX definitely is kind of a cool technology, expensive but cool. Summary, we went over the standards, ISO, IEEE, and some of the hot 802 standards for networking. Now video time. Okay, now this one's a short video. It is 12 minutes and 59 seconds. Okay, it goes over, it was actually created from a company, a networking company, to explain in lay terms networking how it works in a nutshell, how data flows. That's what it's about. So I'm gonna dim the lights. Once we're finished with the video, we're finished tonight. If you have a question before you leave though, on your topic, you can definitely see me before you go, but we're going to watch a video. I will turn the lights off, just promise not to go to sleep. Or if you do, just don't snore. All right. There we go.
For the first time in history, people and machinery are working together, realizing a dream. A uniting force that knows no geographical boundaries without regard to race, creed, or color. A new era where communication truly brings people together. This is the dawn of the net. Want to know how it works? Click here to begin your journey into the net. Now, exactly what happened when you clicked on that link? You started a flow of information. This information travels down into your own personal mailroom, where Mr. IP packages it, labels it, and sends it on its way. Each packet is limited in its size. The mailroom must decide how to divide the information and how to package it. Now, the package needs a label containing important information, such as sender's address, receiver's address, and the type of packet it is. Because this particular packet is going out onto the internet, it also gets an address for the proxy server, which has a special function, as we'll see later. The packet is now launched onto your local area network, or LAN. This network is used to connect all the local computers, routers, printers, etc. for information exchange within the physical walls of the building. The LAN is a pretty uncontrolled place, and unfortunately, accidents can happen. The highway of the LAN is packed with all types of information. These are IP packets, Novell packets, Apple Talk packets. They're going against traffic, as usual. The local router reads the address and, if necessary, lifts the packet onto another network. The router, a symbol of control in a seemingly disorganized world.
Sorry about that. This one here, this one here. This one's here, this one goes here. I don't like this one. Let's go this one, this one's here. A little bit left, let's go with this one here. Another channel here. Let's put that one here. Let's put that one here.
There he is, systematic, uncaring, methodical, conservative, and sometimes not quite up to speed.
Sorry.
But at least he is exact, for the most part.
Was there, that one was there, and this one was there, and that one was there, that was there, he's both there, he was there,
As the packets leave the router, they make their way into the corporate intranet and head for the router switch. A bit more efficient than the router switch plays fast and loose with IP packets, deftly routing them along their way. A digital pinball wizard, if you will.
Here we go. Here comes another one. And it's another. Watch this, Mom. Here goes. Whoop, we're on the back. Hey, in there, in there, in there. Over the left, over the right, over the left, over the right. You got it. Here it comes. Right out. He shoots. He scores. It's going. Hey, wait. Hey, watch out. Here comes another one. Oh, here we go. And it's gone.
As packets arrive at their destination, they're picked up by the network interface, ready to be sent to the next level. In this case, the proxy. The proxy is used by many companies as sort of a middleman in order to lessen the load on their internet connection, and for security reasons as well. As you can see, the packets are all of various sizes, depending upon their content. The proxy opens the packet and looks for the web address or URL. Depending upon whether the address is acceptable, the packet is sent on to the internet. There are, however, some addresses which do not meet with the approval of the proxy, that is to say, corporate or management guidelines. These are summarily dealt with. We'll have none of that. For those who make it, it's on the road again. Next up, the firewall. The corporate firewall serves two purposes. It prevents some rather nasty things from the internet from coming into the intranet, and it can also prevent sensitive corporate information from being sent out onto the internet. Once through the firewall, a router picks up the packet and places it onto a much narrower road, or bandwidth, as we say. Obviously, the road is not broad enough to take them all. Now you might wonder what happens to all those packets which don't make it along the way. Well, when Mr. IP doesn't receive an acknowledgement that a packet has been received in due time, he simply sends a replacement packet. We are now ready to enter the world of the Internet. A spider web of interconnected networks which span our entire globe. Here, routers and switches establish links between networks. Now, the net is an entirely different environment than you'll find within the protected walls of your LAN. Out here, it's the Wild West. Plenty of space, plenty of opportunities, plenty of things to explore and places to go. Thanks to very little control and regulation, new ideas find fertile soil to push the envelope of their possibilities. But because of this freedom, certain dangers also lurk. You'll never know when you'll meet the dreaded ping of death. A special version of a normal request ping, which some idiot thought up to mess up unsuspecting hosts. The paths our packets take may be via satellite, telephone lines, wireless, or even transoceanic cable. They don't always take the fastest or shortest routes possible, but they will get there. Eventually. Maybe that's why it's sometimes called the worldwide wait. But when everything is working smoothly, you can circumvent the globe 5 times over at the drop of a hat. Literally. And all for the cost of a local call or less. Near the end of our destination, we'll find another firewall. Depending upon your perspective as a data packet, the firewall can be a bastion of security or a dreaded adversary. It all depends on which side you're on and what your intentions are. The firewall is designed to let in only those packets that meet its criteria. This firewall is operating on ports 80 and 25. All attempts to enter through other ports are closed for business. Port 25 is used for mail packets, while port 80 is the entrance for packets from the internet to the web server. Inside the firewall, packets are screened more thoroughly. Some packets make it easily through customs, while others look just a bit dubious. Now, the firewall officer is not easily fooled, such as when this ping of death packet tries to disguise itself as a normal ping packet.
It's okay, Gorm. It's okay. No problem. Have a nice day. Be out of here. Bye.
For those packets lucky enough to make it this far, the journey is almost over. It's just a line up on the interface to be taken up into the web server. Nowadays, a web server can run on many things, from a mainframe to a webcam to the computer on your desk, or why not your refrigerator? With a proper setup, you can find out if you have the makings for chicken cacciatore or if you have to go shopping. Remember, this is the dawn of the net. Almost anything's possible. One by one, the packets are received, opened, and unpacked. The information they contain, that is, your request for information, is sent on to the web server application. The packet itself is recycled, ready to be used again, and filled with your requested information. Addressed and sent out on its way back to you. Back past the firewall, routers, and on through to the internet. Back through your corporate firewall. And onto your interface. Ready to supply your web browser with the information you requested. That is, this film. Pleased with their efforts and trusting in a better world, our trusty data packets ride off blissfully into the sunset of another day, knowing fully they have served their masters well. Now isn't that a happy ending?
You're not too bad, right?
That was very cheesy.
Huh?
That was
You
pretty
weren't
cheesy.
kidding about the cheesy part.
Do what now?
You weren't kidding about the whole cheesy thing.
It was a little cheesy. I told you that, didn't I? Did I tell you
you said
that?
that before the video and you were absolutely right. How old is that?
How old?
Yeah.
It's about 8 years old, 7 years old, something like that. Yeah. But the folks that did it, I thought did a bang-up job when they did it, and it's one of those deals that's kind of timeless as far as the technology that they talk about. So they're not going to change in networking. So, but I hope you enjoyed it. Something short and sweet, but also kind of explains data, how it flows. When you click on a link to where it goes, how data can flow going through the firewall, how data can be met by the firewall rules. And so again, it's something just to wrap your head around some of that stuff you read about in the book, some of the stuff we're going to talk about in here in a more visual way. So hope you enjoyed it. If you have any questions about your topics, come and talk to me before you leave, or if you ever want to volunteer and interested in any of the job postings, let me know. Otherwise, see everybody next week. Good job.